Hello everyone, my name is Muskan from Sri Venkateshwara College of Engineering, and today I'm going to be presenting on the topic Kruskal'S algorithm. So in today's video, we're going to be learning about Kruskal'S algorithm, minimum spanning tree, steps to solve it, and few examples. So what is Kruskal'S algorithm? Kruskal'S algorithm is a greedy method to find minimum spanning tree of connected weighted graph. It sorts edges by weight, then adds the smallest edge to the MST, ensuring no cycles are formed until all the vertices are connected. What is minimum cost spanning tree? A minimum cost spanning tree is a subset of edges that is connected weighted graph that connects all the vertices without any cycles, with the total edge weight being the smallest possible. It ensures the most cost-effective connectivity. Let's see the steps involved. Step 1. Sort all the edges in non-decreasing order of their weight. Step 2. Pick the smallest edge. Check if it forms a cycle within the spanning tree formed so far. If the cycle is not formed, we will include the edge. If the cycle is formed, we will not take the edge. Step 3. Repeat step 2 until there are edges connecting each vertices in the spanning tree with no cycles. Let's see a few examples. So in this example, we can see that there are 8 vertices and each vertex edge has some kind of weight. So here, for example, 1 to 2 it is 8, 2 to 3 it is 7, 3 to 4 it is 9, and so on. Let's see how to solve it using Kruskal'S algorithm. So first step is to find the smallest edge. The smallest costing edge is 1 here, which connects 7 and 6. So what we'll do is first we'll connect 7 and 6 and put the weight 1. Now we'll check for the second smallest weight. Here it is 2. So we can see that here 2, it is connecting 2 and 8, and at the same time it is connecting 6 and 5. So we will put join 2 and 8 and 6 and 5. So the next weight, smallest weight is 4. So here we can see 4 is connecting 0 and 1 here and 2 and 5 here. So what we'll do is we'll connect 0 and 1, 4, and 2 and 5 with 4. So now we'll see the next smallest weight. The next smallest weight is 8 to 6, 6. Okay, but if we join 6 here, it will form a cycle. So we are going to ignore this. We'll go to the next weight. Next smallest weight is 7. So it is 2 to 3 and 7 to 8. Let's see it. Yeah. So 2 to 3, we are going to join 2 to 3 because it is not forming any cycle here. But we'll see 7 to 8. Here we have already visited 7 and 8. So there is no need to visit them again because we have to find the minimum cost of the whole graph. So what we'll do is we'll move on to the next weight. So the next weight is 8. The smallest next weight after 7 will be 8, which connects 1 to 2. So if we connect 1 to 2 here, it is going to form a cycle. That is why we have to ignore this. So the next smallest weight after 8 is 9. So here we're going to connect 3 to 4. And now if you observe it carefully, we have visited all the nodes and we have got the smallest cost. Here the cost will be 37. Let's see another example. So this is the initial graph given to us. So we can see there are 5 nodes, 5 A, B, C, D, and E. So we have to find the smallest cost here. The smallest cost is 1. So we will join E to D. After E to D, it is 2. So we will join A to B. Now after joining these two, the next cost is 3. So we're going to join B and E. So after joining all this, the next cost is 4. But if we join 4 here, it's just gonna form a cycle. That is why we must ignore this. So after 4, it is 5. So if we join 5, we'll get E to C. So now we've visited all the nodes at least once, and this will be the minimum cost of visiting all the nodes. Let's see another example. So this is what it is given. So we have 6 nodes, A, B, C, D, E, and F. So here we have A to C1, A to B6, A to D5, and B to C5, C to D5 again. C to F it is 4, E to F it is 6, and B to E it is 3, E to C it is 6, and D to F it is 2. So our step 1 is finding the smallest cost. Smallest edge is A to C, which is 1. So we're going to put a line at A to C like this. After that, the smallest cost is 2, which connects D and F. So we're going to put another line D and F. The next cost is 3. So we'll connect B and E here. So I've connected 1, 2, and 3. So the next cost is 4. Here we can see that C to F has 4. So we are going to connect these two nodes. And then the next minimum cost is 5. Now, so we have 3 edges which have 5. A to D, C to D, and B to C. Now, if we connect A to D here, these are already connected. So if we connect it here, it is going to form another cycle. So we have to ignore A to D now. We'll see the next possibility, which is C to D, which has 5. So if we connect C to D here, which has 5, so it's going to form another cycle. So we have to ignore this possibility too. So the next possibility is B to C. So B to C, if we join, there is no cycle forming here. So it is fine. So we'll join C to B. Now, after joining all this, we can observe that all the nodes are visited at least once, and this will be the minimum cost. We don't need to visit the nodes again and again. So this is the minimum cost. We use Kruskal'S algorithm. Thank you for watching.